Okay then, so back with question 5. The chart shows the region of the electron, blah, 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 blah. Describe in terms of their properties and how they're arranged in this order, okay? So, big things here. They got properties that are pretty much identical. They all transfer energy, they all move at the speed of light, and they're all a transverse wave. So that's the 3 things. So I've written it there. So the properties are identical. Waves travel at the same speed, speed of light, and they're all transverse waves. So they can travel through a vacuum. Otherwise, how on earth could we get sun to us? Okay, visible light. They are ordered from left to right in terms of longest wavelengths radio first, and then shortest wavelengths in gamma. And because of that, therefore, the frequency and the energy of the waves are low at the left, so they're low at radio waves, low frequency, and high at gamma. And the other thing I've said, the higher the frequency of the wave, the more damaging it is to human cells. You could also say the higher the frequency, I don't know why I did that then, I'll undo that. The higher the frequency, the more energy it's going to transfer. So they all transfer energy. Maybe that should have been one more there. They all transfer energy, but that wasn't in the mark scheme. But it should be there. High exposure to either ultraviolet or infrared can be harmful. State and explain the effects of overexposure. So UV, because the UV protection cream and all that, we need to wear it in the sun because it can damage your skin, it can damage your cells and cause cancer. Whereas infrared, it can result in skin burns. If you put your hand in a toaster, I'm sure it would burn. But I'm going to say UV is more damaging to the human body because it's higher ionization energy. It's got a higher frequency. Okay, so if you look, infrared's down here, ultraviolet's there. So generally, the more towards this end you get, the more damaging it is. Question 6 then. The diagram shows some water waves that have been produced by a small earthquake. How many waves are there between points A and B? Well, let's have a look. The easiest way to do this is just draw a line across, and then that becomes easier to count then. So you got 1, 2, 3. 3 waves. Calculate the wavelength. Well, 90 meters gives me 3 waves. Therefore, wavelength is going to be 30. 90 divided by 3. How many times is 3 going to 90? A boat at P, so there's P, moves up and down 5 times in 10 seconds. So how many times is it going to move in 1 second? Again, it's a frequency problem. So if it's moving 5 times in 10 seconds, then it's going to move 0.5 in 1 second. So 5 divided by 10 there. Select and use the equation on page 2 to calculate the speed. Well, if I show you, we're going to use this one. Speed equals wavelength times frequency. Well, I know my frequency and I know my wavelength, so it's going to be 0.5 times 30, 50 meters per second. Don't bother drawing the arrow, that doesn't really apply to us, but you can see I've put my formula there as well. Another question then. The diagram represents water waves on a surface of a swimming pool. Okay, bit of a complex diagram going on here, but let's see if we can make head or tail of it. How many complete waves are shown in the diagram? Well, you've got 1, 2, 3 again. Which letter shows the smallest, shows the amplitude of the wave? Well, it's going to be A, distance from that center there, so it's called maximum displacement. Okay, conversely, it could have been at the bottom, but the arrow's shown there. Okay, there's no other arrow that shows the amplitude. It's definitely not this one. Okay. Select the word from the box to complete the following sentences. I think I just realized they say a lot. It's just me thinking. The number of I tried not to do it now. The number of waves per second is the frequency, and the maximum displacement of the wave is the amplitude. A wave peak takes 0.5 seconds to travel the distance labeled B on the diagram. The speed of the wave is 20 centimeters. Use this equation, distance equals speed times time, which is this fella right at the bottom. Look, there she is, look. To calculate the distance. So, 20 centimeters per second is your speed. And then time is that one. I mean, that's an easy 2 marks. They're not going to give you anything like that on a higher paper. So your distance is 10. Calculate the wavelength. Notice how it doesn't say use an equation here. So I need to be clever and say there are two wavelengths from A to B, which are there. Right? So there's A to B. Huh? What have I said there? Talking nonsense. Oh, right. From there to there is 1, 2. And it's telling me... what's it telling me? Have I lost myself by here now? I think I have. Right. The wave peaks... All right. So, yeah. So this is 10. I've worked this out for that arrow B to be 10. So 10 divided by 2 equals 5. It's because there's actually two wavelengths from that distance of B. I don't know why I've said A to B confused me there. So the arrow for B is 1 wavelength, 2 wavelengths. And if B has got a total of 10 centimeters, so I can actually write that in like that, 10 centimeters from here to here, then 1 wavelength must be 5 centimeters. All right, so I've lost everything now a minute. Ah, there it is. So if I chuck that over there. And then the last bit to that question, water waves are transverse. Give another example of a transverse wave. Well, any electromagnetic wave. Sound waves are not transverse waves. What type of waves are they? They are longitudinal. Remember the examples. For transverse, it's going to be any EM wave. So like things like light, and then sound is going to be your longitudinal. Needs a medium to move through. And then I wonder if I can just get this now and then. That's what I want. That's what I want to do. The diagram below shows parts of the electromagnetic background. Use only the regions of the background to show the diagram. Blah. All right. So what's it say? Name the region of the EM spectrum with the longest wavelength. It's going to be the microwaves. Okay, longest wavelength. Radio waves are down by here, but it's not in there. Name the region of the EM spectrum with the lowest frequency. Again, it's going to be microwaves, because this is the highest frequency at this end. So this is a low frequency. If it's got long wavelengths, it's going to be low frequency. Name one region of the EM spectrum that's not shown. Well, it could be radio, it could be X-ray, and it could be gamma up here. Red Martians invade Venus using X-ray guns. Waves can either be described as transverse or longitudinal. Sound waves are an example of longitudinal waves, whereas visible light is transverse. Brilliant. Ultraviolet waves are longitudinal waves. That is incorrect. You just told me there. Longitudinal waves cannot be reflected. Well, they can, because sound can be reflected. Microwaves are transverse waves. Yep. In a longitudinal wave, the vibration of the particles are parallel to the direction of the wave. Now, well, that's a little bit naughty. It is correct, because it's not at right angles. And if it's not at right angles, it's going to be parallel. So remember, longitudinal, the vibrations go in the same direction as the direction of the wave. So that is correct. It's parallel. And then sound waves travel slowly in a vacuum. That's nonsense, because sound waves can't travel in a vacuum. Simple as that. They need particles to do it. The table below gives some information. Use the equation. It's probably one of the easiest questions. Okay, so you're literally just picking out the information now. They give you the formula. Wave speed equals frequency. To do calculate sound, speed of sound in air. So frequency is 170. Wavelength is 2. Oh my god, what an easy 2 marks that is. The sound waves travel from air to water. Its frequency stays the same. Without further calculation, explain whether the speed increases, decreases, or stays the same. Well, the speed will increase because the wavelength is increasing. Okay? So that is pretty much that paper done. Lovely.